Okay, this time we're a 60% free throw shooter, and we're going to shoot till we miss. All right, Matt, is this a binomial distribution?
No.
No, why not?
Because you're going until she misses, which doesn't give you a set value for how many.
Yeah, and there's not a fixed number of trials. What's different about this problem is we're not just going to shoot 10 or 20. I don't know how many free throws we're going to shoot. How about the other three, though, for binomial? Are they okay for the other three? In other words, is there a success or failure?
Yeah.
Are they independent?
Yeah.
And it's probably stay the same.
Yeah.
So the other three are fine. But the one that breaks here is not, there's not a fixed number of trials. There's not a fixed number of free throws that we're going to do every time. This type of distribution has a special name. We'll get to it in a second. It's called a geometric distribution. But I wanted you to go ahead and fill out the probability distribution function anyway. Okay, what's the first thing, Matt, on this side that's different on this particular type of distribution than a binomial?
You can't take 0 shots.
So it starts at 1. It starts at 1. Okay, so there is no 0 in this particular type of distribution. And what else is different about it? It keeps going 2, 3, and it actually never ends. We'll talk about that in a second. We do know that those probabilities better add up to 0, add up to 1, so if it never ends, how's it going to add up to 1? We'll talk about that. All right, so how'd you figure out what is the probability that you're only going to take one shot?
It's 0.4.
And how'd you get that?
You miss on the first one.
Yeah, what is the probability of missing on the first one? Now, as I said, some of you, you drew a tree to kind of help you get through this. We did the same kind of tree Monday, so making, that's 0.6. Missing is 0.4. Let's kind of get this thing going. Making, missing, making, missing, 0.6, 0.4. So how did you go down the tree for this one, for the 0.4?
Well, you didn't make it, so you had to miss to only take one shot because you just did 0.4.
Okay. What about this stuff over here?
That stuff doesn't matter because you're not taking another shot after you miss the first.
Okay, does it exist? On your tree, does this part even exist? And the answer is no. In the binomial world it did, but it doesn't here, does it? Because once we miss, we're done. So there's not a second shot when I go down this particular branch. So I agree, 0.4. All right, but things get a little more interesting here with 2. Now, what are the chances that I take 2 shots?
0.24.
How'd you get that?
You, well, taking 2 shots means you make the first one and then miss the second. So you
multiplied your weight.
6 and 0.4.
Now, wait a minute. Now, remember that whole binomial thing? We had that choose thing in front because that told us how many different ways down the tree there were. Well, how many different ways down the tree are there for this one?
There's only 1.
There's only going to be 1. So I'm going to show you the formula for this in a second, but you're not going to see any crazy choose thing in the front because there's only 1 way down the tree for every single one of these scenarios. So you told me, you gave me the final answer, but I'm going to write it a little bit different way. So you're saying I needed to make and then miss. Is that correct?
Yeah.
That makes sense? So for there to be 2 shots, I got to get 1 make and 1 miss. All right, how about 3?
You have to have 2 makes and then a miss, which is 0.144.
Oh, and how many ways down the tree are there for that?
It's only 1.
Still only 1. So you see how this is different than binomial? There's not multiple ways these things can happen. These can only happen 1 way. So if I want 3 shots, it looks like I need 2 makes and a miss. And how about for 4 shots total?
You need 3 makes and then a miss.
3 makes. Okay. And this keeps going on and on and on indefinitely.
Could you use a formula to predict it? Like I came up with a formula that...
I wonder if it looks like that. All right, I'll give you a second. Go ahead and copy these down. All right, what is a geometric distribution? A geometric distribution is just like binomial. Okay, 2, 3, and 4 are exactly the same. It just has one difference. And the one difference is you go until one thing happens. Okay, I'm not going to go until I miss 3 or miss 4. That wouldn't be geometric. You go until one thing happens. Now, your book calls it a success. And this can be kind of confusing because what would a success be in the problem we just did?
Miss.
Missing. So, don't, I don't like the word success here. I wish the book didn't use it, but if you see it in your book, I don't want you to be confused by it. I wish it said you'll continue until one thing happens, something different happens, or the opposite of what's been going on. Okay? So don't get confused by that. So in this particular problem we just did, the probability of making a shot was 60%, but the probability of a success is 40% in how we're going to do this. Now, I don't know why, but they don't put geometric formulas in your green sheets. It's the only kind of formulas that we have in AP Stats, and they're not on your green sheet. So these are formulas that you are going to have to commit to memory. But you said you think you got it on your own. I don't know who said that. Somebody said you think they got the formula on your own. Well, this is it. Now, it looks uglier than it is. So let's think about what this says here. The probability that there's going to be 4 shots, that means I'm going to have 3 makes, and then I'm going to have my miss. Does that make sense? So how you would do a problem like this, so the probability of having 4 total shots, that's going to be 0.6, or 1 minus 0.4 to the third, and then I want my success. In other words, 0.6 to the third times 0.4, which is what you guys figured out over there. Okay, so I want make, and then miss for the beyond the 4th one. Okay. All right, a couple of other formulas that aren't there for you. The first one, what is the mean of the distribution going to be? Now remember, the probability for success in this problem is 0.4. So to calculate the mean, it's 1 over the 0.4, or 2.5. What does that mean? If somebody does this many times, on average they're going to take 2.5 shots. And then the variance, this is the formula for it. So this would be, on top would be 0.6, on the bottom would be 0.4 squared. Then square root that, and you've got the standard deviation around 2.5. All right, fortunately we do have nice calculator buttons for this. We'll talk about this in a second. But this is the interesting part of this. This is what you guys were kind of stumbling with in your warm-up. This could theoretically go on forever, right? If I keep adding up probabilities, how in the world, if I keep adding up probabilities, could it ever equal 1? All right, I don't know if any of you guys have seen this before, but let's do this. Let's say I'm standing back here, and I'm going to walk halfway to the wall every time. Here I go, I'm going to walk halfway, stop. 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 First question, do I ever get to the wall? No. Never going to touch the wall, right? But how far am I walking, after a while? Not at all. I mean, think about this like that. If I'm a 60% free throw shooter, what are the chances I'm going to shoot 10,000 free throws and then miss one? Is it possible? Yeah, so I guess there would be a probability, but how many zeros would that thing have in it? So do you get the point? It kind of, you calculus freaks, it kind of has the limit of 1. Never quite gets there, but it is there. So you can continue adding, but it's never going to go more than the 1. Is that okay? So it would be nice to know what 5 and beyond would add up to. There's a couple of ways you can do this. Think about this. Isn't 5 and beyond just going to be add these up and subtract them from 1? Right? 1 minus the CDF of 4. Right? That's one way to get it. But your book also gives you a formula for it. It's derived. How they derive this formula is in your book. Gives me a headache. I'm not even sure I quite understand it. But it is derived in your book if you want to look at it. Zane, you want to take a look at it and derive it from there? No, but this is the formula for it. And this is the way I kind of think it through. This is the probability that you're going to take more than 4 shots. So this is really saying 5 and beyond, right? Forever. And the formula is, hey, let me just make 4 of them. And then everything that comes after that, it might be make and miss, it might be make more of them and miss. All the other combinations come after that. So that's the basic formula. So this 1 minus these is that same number. Okay, and again, these are not on your formula sheets, but a way you can remember it If I want to shoot 5 or more, then I'll just make 4 of them. That's really the formula for 5 or more. All right, I said you had a couple buttons on your calculator. Go get them. We've got to treat them a little different. It's geometric, so it's in your distribution. Now again, you got to write the formula, you got to plug in the numbers, but you've got this calculator button that will is programmed for those formulas. Okay, so it's back in your distribution. It's all the way at the bottom on mine. And here's your geometric PDF. So what do we not have in geometric that we had in binomial? We don't have that fixed number of trials, right?
Yeah.
And that's what we put as the first parameter, so there's nothing to put there. So we just put the probability for success. Now remember, the success probability is when it stops. Okay, so here I have 0.4. And then if I wanted to figure out the probability for 3, 0.144. Isn't that what you guys got here for that? 0.144. Okay. It also has a CDF button. So if I do the binomial, the geometric PDF, or CDF, again, 0.4, comma 3. Now remember what that's going to do. CDF's like the percentile. It's a cumulative button. It's going to add these 3 up. Okay, last new thing of the chapter. The first one was a binomial distribution. This is the geometric distribution. The only difference is it's not a fixed number of trials. We're going to go until one thing happens and then we're going to stop. Several formulas we got to know. They're not on your green sheets, but at least that one for sure you could do on your own with a tree. Questions, comments?